Okay, we have a MacBook Pro. This is 16 inches. It says no power. So the 16 inches, the Intel's, the model numbers will be A2141. Yeah, so that's the model number, and it says it's a no power. So on this one, we're really gonna hope that it's not an issue with the SSDs, because the 2141s, they commonly have the SSD failures where your U9080 blows out and then it damages sends 12.6 volt to your NAND, which is supposed to receive 2.5 volt. So we are really going to hope that that's not the case. Okay. Okay. Yeah. Again, this it's been attempted. Say the screw here is missing. Mm. Okay. First thing we're going to do is we are going to disconnect our battery cable, which is this guy here, and then we want to see if we have a short on our PP bus line. So that's what we would commonly do. The board number, it's going to be 80-01700. That's the board number. And measuring for short on the PP bus line, we are going to use. Sisi, thank you so much, eh? You don't mind? Thank you. Oh, yeah. Okay. Bye. Yeah, thank you. Do you want to have something cold? I can give you. Can grab cold water in the fridge. You can grab. Yeah, you can just. Fridge is there, see. Straight left. Water. Okay. So we are gonna check for short on using F7000 and F7001. Those two guys. This here. This two. And when you're checking for a short, you set your multimeter to continuity mode. You make sure that you don't have power on that machine or on the board. So we are going to have our black probe on ground, and then our red probe. We'll go see what we have. That's good. We don't seem to have a short on that line. That's a good thing. And then we want to check for short on the 2.5 volt line on your left. So we can check for 2.5 volt here and then 2.5 volt here. So it's hopefully the 2.5 volt line. Hopefully we don't have a short on the 2.5 volt line. We can use either of the cap, C9587 or C9588. So those capacitors are sitting on a 2.5 volt line for the NAND. So let's check to see if we have a short on that. Our left probe on ground and then our right probe. So left probe black, yeah, and then right probe. But it doesn't matter. You can flip it either ways. But okay, we don't have a short that side. Now let's check on this side. The 2.5 volt on the side. Okay, we don't have a short in either. We don't have a short in either we don't have a short on the 2.5 volt line. We don't have a short on the previous line. So the next thing we want to do is we want to connect charger to it to see what voltages that we have on the board. So now we can now we think it's safe to connect charger to it. Now we are going to use our switch our multimeter to voltage mode. We actually using a different multimeter for voltage measurement. So we want to have our black probe on ground and then our red probe. We want to see what is it that we have on our PP bus line. 12.6. That's good. 12.6 would mean that we have 20 volt on our PPDC in. So let's see, do we have feedback on our trackpad? I mean 12.6 volt. Let's also connect to the battery. Let's see, what do we have? Do we have feedback on our trackpad? Yes, we do have feedback on our trackpad. Okay, so the device it's making its way into SO state because we have feedback on our trackpad. So now let us see if the device is actually stuck on DFU mode because we have feedback on the trackpad. Let's see if the device is stuck on DFU mode. Because it's Intel, we are going to use the second port for DFU. If this was M1, we were going to use the first port. Uh, Now on the host machine, it doesn't matter what port you plug the cable to, but on the machine itself, on the target machine, you have to use the second port if it's Intel, and the first port if it was an M1. So let's see if the device is stuck on GFU or recovery. It's connected. I will go to my app. Okay, and we don't see it to be we don't recognize it. So what you want to do now is you want to try to place the device in DFU mode. So we count 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. If it doesn't pick up, we'll have to start again. Now, the four keys that we're using, we are going to be using the Control, the Alt, the Shift, and the power button. So I'm going to try that again. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. Nothing. We're going to try again. Power button. Power button. Okay. So four keys. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10. Okay. So we are in DFU mode. So what you want to do now is that we're going to try to revive, and if that doesn't work, then we can restore. Because if we choose the option to restore, that will erase the client's data. We are going to choose the option to revive. I'm not sure if I have the file already downloaded, but if not, it's going to re-download the file. Uh, okay, so what I'm going to do, we'll leave it to do its thing while it's downloading. And when it's done, we can take it off from there. You can help it. Now we ask him to allow. Okay. Hopefully it goes through. If it doesn't, then we have to reach out to the client and inform the client that okay, we might have to use the option of restore, but that would erase the client's data. That's good, provided it turns nah, yeah, error 6. Okay. Hmm. Okay, that's not so good. Let's try it again. Let's try it again. So I'm gonna try force it off. Okay. Power button. Okay. DFU. Let's try again. So it's already downloaded, so it's not going to download for the second time. It's just going to unzip and install. Hmm. That's not so good. That's not so good. So error 6 will suggest that we might be having issue around our NAND chip. So there is this very there's this very useful site to have. Um, So there you have all of which is the Logi Wiki. There you have informations from fellow techies. Let's see. So if we go to the main page, for example, and then we go down to DFU there. See where it says DFU mode restore. So let's click on let's see let's click on that, and then there you find some of the errors and the descriptions of the errors that you most likely will run into. um, so DFU error code and troubleshooting. So error 6 probably could not write BridgeOS into service progression. Partition most likely SSD failure, which is a NAND failure. There might be one hot NAND. Common symptoms: T2 does not turn on S5 rails at all. If you have it in revive mode, try restore. All data will be lost. So error 6, so I see what it says that this could not probably could not write BridgeOS into service partition. So this is a site where you have technicians contributing repair ideas. So this is also a good site, LogiWiki. There's so many useful informations you can find here. So so yeah, so that's about this. So it's not going through. We are now going to take the board out to get an idea what is going on. Okay, so let's take the board out. We're gonna quickly use a T5, a T4. Sorry, not a T5. We are gonna start with the T4 screws. If this is an issue with the NAND, then we will have to replace the NAND. Now, on the forum it says that so it's an that error can mean that, but that doesn't mean that that's exactly what it can only be that. So you sometimes you will have an issue that might not be exactly an issue, but then you run into the error 6. Although 9 out of 10 when error 6 would point to your NAND, but what you still want to do is you want to leave all options open so that you don't just have your attention on the NAND only. Okay, T4 screws are out. The next thing you want to do is use this now T5. If this is the first time you're doing this, you want to make sure that you take note of your screws. You can use a tool to take to take out your cables, but if you're going to use a tool, make sure you don't hand complete control to your tool. Okay, the board is out. We're now going to physically look around the board to see if anything stands out. Okay, so uh, okay, I'm not sure what somebody was trying to do here. That cap doesn't look good. But that's on the PP boss line. That cap also doesn't look good. That cap there does not look good. So we're going to check what's happening around that side, and then around this side, this cap here also doesn't look good. So there was a cap here, and it was yanked off. Hmm. Okay, so let's, let's check again. Continuity. Let's check. We have multimeter. We black probe on ground, and then our red probe on 2.5 volt line. We don't have a beep. We don't have a beep. And PP bus. Yeah, PP bus. I mean, we had track right. Okay, let's see. What do we have here? No beep. This guy here. We have a beep. And another beep. Okay, so that is gonna go. And what do we have here? We don't have a short. And we don't have a short. Okay, so let's connect power. We don't seem to have a short there. And then this side, let's see, do we have a short on this side? And we don't. And that should be ground. Okay, so let's connect let's connect power to the board. We're supposed to have 2.5 volt on the output of just kind of switch to our board here quickly. Is this the 0? No, this is a different board. Wait, no, this is, yeah, this is the board here. So we are supposed to have 2.5 volt on the two inductors here, L9580 as well as L9581. So let us see what we have. Power connected. Say, do we have 2.5 volt? And we don't. And then the other side? And we don't. So let's see, do we have PP bus voltage? PP bus is 12.6. Okay, so, and how about this side of the board? Do we have 2.5 volt on this side of the board? We have 2.5 volt on this side of the board. Okay, so we have 2.5 volt on this side of the board. But this side of the board, we are also supposed to have 2.5 volt, and we don't seem to have that. You see what we have in 0.13, and then on the other side we also have in 0. So yeah, so that's, we have a problem there, which we just need to, now before we want to worry about that, we want to see the PP bus voltage that goes to that section. Let's see if we have a PP bus voltage going to it. Okay, yes, we do have PP bus voltage. We have PP bus voltage. So what I'm trying to establish now, it's we're supposed to have PP bus voltage going into U9580, and yeah, before U95. Now before we, so another thing we want to do, it's let's see, do we have the enable signal forward? Is it being asked to turn on? So U9580 will obviously need an enable signal. So that is going to be on pin 20. So pin 20 is going to be an enable signal. So let's see if that enable signal is present. That is going to come from the other side of the board. Let's see if the enable signal is present. So the enable signal is going to be generated by this guy here. That guy is going to generate the enable signal. So before we blame the chip, we want to make sure that the chip is being asked to turn on. So we can measure for the enable signal on R95, 9598, and that will be this resistor here. So this resistor here, we want to see if we have if it's been asked to turn on. 1.8, that's fine, and then on the other side 1.8, that's fine. So that's what we should be getting. I'm just going to get another board to confirm. Okay, so it's good to always make sure you have boards that you can get reference from. I just want to be sure that 1.8 is what we are supposed to get on that line. I think that's what it is, but it's good to be sure. So let's see, 1.8. Let's see, that resistor is this guy here. Okay, 1.8. Yeah, that's what we're supposed to get. Okay, then that's fine. So it means that the chip itself. Let's go back. So um R95, the R95 80 is going to get PP plus voltage, which is going to be on 21, 17, 13, 9, 5, and 1. And then also it's going to get an enable signal. And the enable signal, we see that is present, but we do not have output on from U9580. So we are going to replace that. And you want to be very careful when you are walking around, because you don't want to damage. You don't want to send 12.6 volt on a 2.5 volt line. So when you're working on this, you have to be very, very careful. So also what I'm going to do is I'm also going to remove this cap that don't look so good. Let's take the cap out. Also, while you're busy in here, be very careful around your NAND. You don't wanna heat up your NAND. That also doesn't look good. So let's get another board for replacement. This doesn't seem to look bad. So it might be that our problem is not, yeah, but nonetheless, we are going to replace it and take it from there. Just gonna get another board for replacement. Okay, so we can use this one here. So by the way, there are two of that on the 16 inches board. So you have one on the right and then one on the left, because you have two outputs. Yeah. So you have this output here for 2.5 volt. You saw how also on this board we had 2.5 volt on one side, the other one we didn't have 2.5 volt. So the same chip is what you are gonna utilize on both. But then the one thing you want to do is make sure you get the orientation correct. So for example, you see on this one, the orientation is see the red dot, that is going to be your pin 1. And also on the chip itself, there should be a small dot. I doubt you can see it. So there should be a small dot on this side. So that would indicate that the pin 1 is on this side here. The dot is right here, but I'm not sure you can see it. Okay, so so what you want to do is you want to take that. Uh, but I kind of I don't let's see. Okay, so orientation wise, let's confirm how the orientation is. Okay, so pin 1 is this side, so I have to align it like this. Let me see. So like this. Since pin 1 is going to be this side. Okay. Okay, that's installed. And then the caps that I took off, let me also. So when you're walking around this area, you want to be very careful. You don't want to heat up your NAND. Okay, and then there's another one that is it's the closest to the NAND. That's another cap we need to replace. And that's this guy here. So with this one, we want to be extra careful because that is very close to the NAND. Okay. That guy there don't look so good. We're gonna remove it and okay, let's see what are you? What is that? Okay. That doesn't look good. We can just replace it. We can leave it on, but thinking we can just, since we are there, we can just go ahead and replace it. Yeah, I see that. It's not looking good at all. Okay, let's clean that up. So the pins that are corroded, let's see. What are those pins? The pin of U5620. Okay, so pin 3. Okay, it's not so good. It's not so good. There's a constant in line. Okay, seem to be completely missing, and the other one is not connected. That's okay. Uh, okay. That's completely okay. So, you going to the gym today? Okay, let's quickly mix that up first and then we continue. Okay, so what we're saying is U5628, which is a constant resistor. So uh, that is corroded and mm, okay. high side current sense. So high side current sense, which is this guy here. So the parts, there's two parts here, pin 2 and 3. Those are missing. Let me see, where do those go to? Pin 2 and 3 will go to where exactly? Here. So maybe we can, on the other side of the board. Okay. So before we worry about that, let's see what we have on our 2.5 volt line. Okay, first thing first, let's see what we have on our 2.5 volt line. It appears it was liquid in that region of the board, which is what damaged U5620. Mm, okay. So first and first, let's see what do we have on a 2.5 volt line. So I'm just hoping that the circuitry itself doesn't shut down because it's unable to because the center line is not active. So let's see. Let's confirm that we have PP bus on the line. PP bus we can confirm from here. 12.6. Do we have 2.5? Okay, that's good. Okay, we have 2.5. Okay. So we are going to come back to that, but now let's put the board on the shelf and see if we now have a working board. Remember what happened was we tried to do a revive, and then we got error 6, and then error 6 was so basically when you have error 6, it suggests that you have an issue on or around your SSD, and then what we actually saw was we were having no voltage going to the SSDs. One side of which is the SSDs on the left, there was no voltage going to the SSDs on the left, but we had voltage to the right SSD. So which means so because of that, just the device goes into SO state, but it doesn't post. So we tried to revive it, and the revive failed with error 6. So now let's with the 2.5 volt restored, let's try it again and see what we get. So we're still gonna take the board out, so which is and then test and then clean the shell. But right now we just want to see what is it that we get on the board. We are only going to connect the cables that we need for testing. We need the keyboard, the trackpad cable, and this does with this design. Even so, one of the fans is not. That's fine. We're not going to worry about that. So on this design, even though the keyboard has a physical connection to the main board, the keyboard by itself will not work even disconnected to the board without the trackpad being connected, because the keyboard function is routed through the trackpad cable. So if you have your keyboard connected to the board but your trackpad cable is not connected, then your keyboard is not going to function. But then if it is one of those designs where the keyboard the power key is part of the keyboard, then the power key will function as a power key, but other keys on the keyboard will not function. For example, like your MacBook Airs. So you still get the power button working, but other keys will not work if your trackpad cable is not connected. Okay, we also make sure we connect the power button. Let's add one screw. Let's add the battery screw. C5. Can at least add at least one screw to the board. Just close that. In case we need to revive the machine. Okay, uh, we don't have to connect the cables. Just can leave those for now. We can attach at least one speaker. And then let's see. We have trackpad feedback. Let's see if we at least have a fan spin. At least we're expecting one of the fan is still connected, even though the other one is not connected. So let's see if we get a fan spin. So a fan spin will indicate that the device is about to post, or sometimes, and other times you can actually see get the fan spin and the device. Okay, there's no fan spin. We have trackpad feedback. So let's see if the device, because remember the other time we tried to revive it and it failed. So let's see if it's stuck on recovery. So the cable is connected. Oh no, not that one. It's not the. Okay. Okay. Let's accept that. Let's hope the device is stuck on recovery. Okay, that's good. It's good that it's stuck on recovery. So now let's force the device into DFU. So we're going to hold the power button and control option as well as the shift key. So power button, then it shift key. So we keep holding until it goes off, and then it goes into recovery. Oh, from recovery to DFU, sorry. Yeah, that's what I want to see. Now let's try to revive again. We hope it goes through this time. We hope it goes through this time. I think I just saw Apple logo now. What is that? That's very. I don't understand. That's not usual. I mean, that's not the normal process. Uh, okay. I hope we get the lock sign. A lock sign will be good, which will mean that the process was successful. That's beautiful. Okay, that's good. So we are going to press and hold down the power button until it disappears, and then power the device back on. Now let's power the device back on. Alhamdulillah, it went through successfully. We have feedback on the trackpad. Yes, we have feedback on the trackpad. So we are just gonna wait for the device to boot up. Sometimes the device, or if you don't have the patience to wait for it to boot up, you can disconnect the battery, disconnect the charger, and then reconnect in order for the device to start. So it's powered on, so we're waiting for it to start. And that's it. So let's see if client's data is still safe. Alhamdulillah, client's data is still safe. I mean, it is booting to desktop. That's a beautiful thing. Now, there's something I want to okay, so I want to see how the device is going to behave without. Yeah, so I'm just going to cover the client's name. Yeah, I'm just going to cover the client's username. So okay, so as you guys can see, the device is 100%. So what we're going to do is we are not going to put back. Okay, I'm just going to shut it down. We are not going to put back this guy here. Where are you? We are not going to put back U5620. We're first going to run the device. So we want to see, first we're going to see how the device perform without U5620, and then we can decide if to install it or not. But but as far as the repair time is concerned, the repair is complete. So I'm just going to do a recap of what the issue was. So the device came dead, no power. We tried to check. I'm just gonna disconnect all of that. So the device came dead, no power. So what we had to do was, and the device was clearly in for repair somewhere before. And then what we had to do was to check to see if we have a short on the board. We didn't find a short on the board. And then we found that we have 12.6. And then we also found that the trackpad, after which we connected power, and then we got 12.6 on the PB bus line. And then we also saw that we're having feedback from the trackpad. Now, with these devices, with the inception of the 12 inches 2015 as well as A1502 2015. So that was when Apple made a redesign to their trackpad, whereby now that the device is off, there will be no feedback on your trackpad. But once you have power on the machine, you will get feedback on the trackpad. So basically, the trackpad itself and the body of the machine will be of the same. But when you have power, then you will get feedback from the trackpad. So when we checked, we found feedback on the trackpad. Then we decided to check if the device, it's because that would be a behavior you get should the device be stuck on recovery. So we checked to see if the device is stuck on recovery, but that was not the case. So we decided to then put the device in DFU mode. To put the device in DFU mode, this is for all Intel devices. You use the left-hand side, the second port on the left-hand side. So this is the first port. The first port is to be used if the device is an M1 device, but if it's Intel, you use the second port. Now, the port, the host machine, which is the machine that you're going to use, it doesn't matter what port you use, any of the port can be used. Mind you, sometimes you may get failures that result from the type of cable that you use. So you see what I did on mine, because sometimes so I actually mark my cable because I know this cable is fine. I actually mark this cable. So this is what I use for my revive and restore options. So we then had to connect the cable to the second port, and we found that the device was not in recovery. So we then had to manually put it into DFU mode, and then we tried to revive. The reason why we did revive was because the client did not give us a go ahead to erase the drive. And also, whenever you are whenever you are troubleshooting and then you needed to use your Apple configurator tool to do a revive, to perform any type of operation, it is better to revive and not to restore, because when you revive, the data is saved, but when you restore, the data is deleted. So we then had to put the device in DFU mode. We tried that, and we got error 6. So what we did was we had to go to so I showed you guys how helpful this the Logi wiki site can be, where it lists out there's so many informations that you will find here. Of the information that you find here, it's the error code of 6, which is what we got. And here it says probably could not write BridgeOS into service partition. Most likely SSD failure. There might be one hot NAND. Now, what I said was, now this is a hint towards looking into your SSD region. It doesn't mean that you will have exactly the same scenario that is described here. In our own case, we didn't have the exact same scenario. None of the SSD, none of the NAND was getting hot. But what we had was the left side of the board didn't have 2.5 volts. So we had 2.5 volts. So when we came back to the board, we found that we had 2.5 volt. I'm just going to switch it back. So we had 2.5 volt on the right side, which is what will feed the left side of the left NANDs, the right NANDs on the right. However, which is going to be regulated by U9080. However, the left side, we didn't have 2.5 volt on the left side, which was going to be regulated by, let's see, regulated by the same chip, which is U9580. However, the chips are the same. And then another thing about that chip, you can find that chip not only on the 16 inches, you can find that same chip on 13 inches, as well as 15 inches. You can find the same the same chip. It doesn't have to be, you don't have to get, if you don't have a new one, you don't have to get it exactly from a 16 inches. You can get it from a 13 inches or 15 inches. So we replaced it, and then while we were doing so, we also found that U5620 was corroded. So we decided to remove it, and we're supposed to replace it, but the pin 2 and 3 of it are missing. It's a current sensing line. So we here where is it again? Current sensing line. Right. Did we close it? Okay, yeah. So it says 12 volt SSD high side current sense key. So it's a current sensing. It's a current sensing. U56 is going to sit on the current sensing line. So what we decided to do was, first of all, we had to address the 2.5 volt issue. The board is currently going to run without U5620. We are going to test. We are going to see how the board performs, and then we can decide if to have it back or not. So U9580 we decided to put back, obviously because we needed 2.5 volts to our NAND. And after that was done, we test the device, and then we saw that the device powers on, same as in the state that it were before, but it's not posting. So we then connected the device to our host machine, and then we saw that the device was in recovery. That is expected, especially if you do any type of repair around your SSD. So we did a revive, and we saw that the revive was successful, and the client's data is still safe. And that's about this device. And thank you guys, and then I will hope to see you guys in the next one. I'm just going to power the device on again just to see that the device is working. Let's see. I'm going to hold down the Alt key because I don't want the device to boot to desktop. Holding down the Alt key for Intel devices will give you access to choose your boot path, where you want to boot the device from. Now, this is not going to be the case if it's an M series. If it's of the M series, you're not going to hold down the Alt key. You're going to hold down the power button. So you have to hold down the power button, and it tells you to keep holding while the device loads its startup option. So as you guys can see, the device is working. We are going to so let's basically see how the device perform without a U5620. But other than that, thank you guys. I will see you guys in the next one.